So even though you get episodes continuously, I record them almost 10 to 20 on a single day. So I'll be wearing the same t-shirt. So anyhow, let's start with the Big Bang theory. Big Bang theory is very easy theory, and also widely accepted theory. In this episode, we are going to cover everything about Big Bang theory, including the criticism what regarding the Big Bang theory. So let's start with the criticism also. So basically, what in Big Bang theory or expanding universe theory tells is Big Bang theory or expanding universe theory, there are two names for it. And in the second name itself, you will get everything regarding the theory. It is expanding universe theory. So universe is expanding. Universe born in a huge fireball around 13.7 billion years ago. So this is just a fact, everybody knows it. I'm just taking you into the concept of Big Bang. Big Bang was the beginning of everything. Time, space, energy, matter, whatever it might be. As per the theory, before the Big Bang, there exists nothing. There exists nothing. So Edwin Hubble, he's a scientist. Later we named Hubble telescope on his name. So Edwin Hubble provided universe is expanding. How did he provide universe is expanding? This is what we want to know. Edwin Hubble told that universe is expanding. How did he tell that universe is expanding? Because of something called as redshift. What is redshift and all we'll see in a minute. But galaxies are usually moving apart. What are galaxies and all? This is the topic for next episodes. Don't worry, we'll cover that what are galaxies in depth. But galaxies are moving apart. Galaxies, consider they are more like we are in the Milky Way galaxy. We have multiple solar systems inside Milky Way galaxy. So it's a bunch of solar systems. So two bunches of solar systems are moving apart, and matlab there are multiple bunches of solar systems. They are moving away and they are expanding. That is what the theory tells. Expanding universe theory. Simple. Redshift. We are going to talk about some technical thing that is called. You should know something called as color spectrum WebGR. So WebGR, which means that violet to red. So whenever the galaxy or the light is observed that is moving away from you, then what happens is wavelength will shift to red side. That is called redshift. To get a clarity, I'll make a video and I will attach that video in the description, because I cannot talk about redshift too technically here, because this video is completely related to Big Bang. Remember like this, if light is moving away from the source, whatever the light might be, light is moving away from the source, so the wavelength of the light will be moving towards red color. So that is the reason you see red shift. So what he have done is he have observed that one star is going far away and then we are getting red shift. I mean the wavelength of the light is moving towards red. So it is red shift. Whenever the red shift is happening, then automatically we can say that that is moving far away, which means that it is expanding. That is what we can get a clarity from the redshift. So let's get into the main topic. Universe began as singularity in a tiny ball as per the Big Bang theory. Big Bang led to rapid expansion of universe. During expansion, some energy was converted into matter. This converted into matter within 3 minutes of Big Bang. Big Bang is a very big force, very big thing, but in very matlab compare that particular size and then compare with the 3 minutes or the amount of time it is taking. Within 3 minutes the first atom is formed. First atom began to form within 3 minutes. Matlab it is very fast. The first atom was began to form and then slowly cooled from steady state density. It got slowly cooled, and then once everything is cooled, there is a singularity which got suddenly blasted or with a big bang, and then everything started to cool down. Once the cool down is happening, then the four fundamental forces of the universe started to exist. The first fundamental force you have to remember is gravity. You find gravity even in space. So gravity, and then weak nuclear force, and then electromagnetic force, strong nuclear force. These are the four forces, four fundamental forces that came into existence after the Big Bang. Weak nuclear force and strong nuclear force, you know, they are between atoms and atom level. So after atom formation, we get those forces. Even gravity and electromagnetic forces existed after the Big Bang itself. That is what Big Bang theory tells us. So basically, gravity is the weakest force, but the field is infinite. Recently, we have found gravitational waves in space also. So, field is infinite. Nuclear, strongest, but very short range. Very minimal, not even this much. It is atom level. That is what Big Bang theory tells us. And then scientists have wide range of observational evidence, including cosmic microwave background radiations, and then large scale structure of universe and abundance of light elements. They have studied a lot before giving this Big Bang theory or Big Bang hypothesis, because hypothesis is accepted as theory enough. It is widely accepted that Big Bang is what happened, and they believe that. This is what we know about the Big Bang as of now. It is more than enough to cover an answer, and then we are going to now see what criticism have come, and then what are the arguments in the criticism, and what explanation regarding to those arguments we are going to know about that now. So first thing is, it is against the first law of thermodynamics. Basically, for that, scientists have told that laws usually break down when you approach creation. If there is no creation, there is no law. So if you approach back to creation, then there won't be laws. It violates law of entropy also. Law of entropy also, same thing. Laws usually, if you go, matlab, current right now, entropy exists. Entropy exists. There is no bigger changes. Entropy exists. But in the earlier universe, it won't be existed, because when you go to creation, laws usually won't exist. That is what scientists have explained. Against the speed of light. Against the speed of light. Of course, it will be against the speed of light. It violates nothing can be faster than light. That is what the speed of light, na? Nothing can be faster than light. We don't know nothing can be faster, because when they come back, it is usually more than billions of years ago, billions of years when they come back, if everything comes back. So that means that some particles have traveled faster than light. This is what they are saying, that against the speed of light. So recent findings of gravitational waves in space, as I told you, image of the black hole, or corroboration of expansion of universe and space-time fabric as proposed by Einstein in special theory of relativity. Space-time fabric, I know you know the theory of space-time fabric. Either you Google it, read for 2-3 minutes, you'll get it. That is what for this episode and the Big Bang theory. Hope you like it. We'll meet in the next episode.